Hello, everyone. Thank you for taking time out of your valuable day in attending the Buki Corporation webinar on implementing NIR technology into the flour milling industry. My name is Jacqueline Russell. It is always a good day when you learn a tidbit or two about the technology you are using. I will do my best to offer you that kind of day with this presentation. The webinar is geared to speak directly to flour millers. However, it is applicable to other industries as well, especially industries with high volume running 24/7 with 3 production shifts. You have an opportunity to type in questions that I will answer at the end of the presentation, or you can contact me directly and I will be happy to clarify or expand on any of these topics. So let's begin. When I first started working with flour and NIR in 1998, I naively thought, this should be easy. Homogeneous white powder, no problem. I had spent the previous 2 years working with the meat and dairy industries and understood the challenges they faced with NIR. After the first couple weeks supporting flour milling technicians, I quickly realized wheat flour is not a simple, homogeneous white powder. Every flour mill is unique. Every crop year brings uncertainty, and one way I have illustrated it, the mills are pushing pennies out of each and every wheat kernel. And just when I think I have seen everything, I still get that occasional curveball. You may not realize, but the first commercial NIR spectrometers were developed in the early 1970s to measure protein in wheat. It all started with you. I always like to share a little history because I think our combined history, flour milling and NIR, is pretty cool. This is a picture of the old Pillsbury Mill and Mix plant on the north side of Springfield, Illinois, less than 3 miles from my childhood home. The first mill was built in 1930, and by 1949 they had opened a bakery mix plant. Our newspaper claims it was the most modern mill plant in the world at that time, because flour from 3 mills was pneumatically transferred to the mix plant. In its heyday, this Pillsbury operation employed 1,000 people. Many of my neighbors worked here. Cargill purchased the mill in 1991 and closed it 10 years later. In the late 90s, I supported their laboratory NIR, and their main building, which housed the lab, was literally like walking back into history. It was this huge brick building with a grand entrance, high ceilings, large stairs, gigantic unused bake labs. Today the property is abandoned and slowly deteriorating. And I'll tell you what, they do not build facilities like that anymore. During our time together, we will review some of the basic NIR theory and statistical analysis. I always recommend we remember some facts about the science behind the technology. When I am analyzing a problem with NIR, the real science is indisputable. Together, we can rely on it. I will review some ideas about easily implementing a new NIR into a flour mill. And this year, I've been talking a lot about NIR competence and what this means to you, the flour millers. I will also take this opportunity to introduce our newest Buki NIR product, NIR Online. Then, of course, I'm available for questions at the end of the presentation. As you know, NIR has been quite a handy tool in the flour milling industry and a lot of other industries for that matter. Modern NIR spectrometers have robust standard wheat flour calibrations. So once a small series of samples has been compared with the reference lab, routine users do not really need to know much about the science behind NIR. Therefore, it has always been a bit mysterious. How does this box tell me my moisture, protein, and ash? And if the black box does not give me the answer I want, or does not give me the same answer as the lab, now we have a dilemma. This is where we have to fall back on the science. When routine operators are seeking guidance on their NIR, sometimes it is explained to me, and I quote, "The numbers are jumping around." While I am certain that this is in fact what the operators are experiencing, they are really pointing at the black box as the main culprit of the discrepancy. It is a mystery they can't explain. And this is where we have to fall back on the science. I can assure you the NIR spectrometer is more than likely the most stable piece of the puzzle. There is not a little guy jumping around in the box causing the numbers to jump around. NIR technology takes advantage of the interaction between light and matter. We are looking at a wee little portion of the electromagnetic spectrum, just a bit longer than the visible wavelengths. Your eyes are also spectrometers if you think about it. Your eyes see wavelengths in the visible portion of the electromagnetic spectrum. Your brain is like the computer that associates a word, red, blue, green, to this wavelength information. And your brain has to be calibrated. You were taught as a child that red is red and blue is blue. It wouldn't have been very nice of your mother to hold up something red and teach you the word green. You would have been improperly calibrated. When the children are learning their colors, they are essentially calibrating their brains to visible wavelengths. NIR technology works in a similar fashion. You show the spectrometer a sample. It compares that sample to what it looks like in the NIR with calibrated samples in the NIR, and you get an answer. If you teach it with accurate laboratory data, the NIR will be accurate. If you teach it with inaccurate laboratory data, the NIR will be inaccurate. Now, this is simplifying the technology quite a bit, but I think you understand the analogy. Organic molecules exist in vibrational energy states that absorb NIR wavelengths. The key point here is that it is the vibrational energies of the molecules that do the absorption. We are not knocking electrons into outer orbitals. In the vibrational energies of specific organic molecules, like water, protein, fat, they absorb specific NIR wavelengths. And I keep saying the words organic molecules. This is also very important. NIR and organic molecules have a nice relationship. And in order for it to work, we need to be looking at primarily OH, CH, or NH bonds. I get the questions all the time. Can NIR measure functional properties of gluten? Or can NIR measure chlorinated versus unchlorinated flour? The only way NIR can measure these things separate and apart from organic molecules is if the property of interest directly influences something organic in a correlated linear fashion. Sometimes these things work okay, and sometimes not. There is a lot of research out there on measuring these functional properties. Some of it is conflicting. If you have any questions or want to attempt a calibration on your own, please let me know, and I can consult with you. Here is a beautiful spectra of a flour sample. You can see that the whole spectra is dominated by the water bands with these large water peaks. There's also protein information in there as well, although it's not as visually defined. Fat is recognized by the CH bands. The spectra is what I call rolling hills and valleys. You cannot easily see varying concentrations of moisture and protein. We have to use sophisticated mathematics, or what we call chemometrics, to extract the information out of the spectra and develop the linear calibration. Buki typically does this part for you, unless you want to do the chemometrics yourself. We can teach you how. But most flour millers are too busy milling flour than to have to worry about building their own robust flour calibrations. So let us do that work for you. Understanding a little bit about the science does take away the mystery and helps you build confidence in your NIR. This is what the result page looks like on the Buki NIR Master. And you can see next to each result is a green check mark. These check marks indicate two things. Number one, the sample is spectrally similar to the calibration sample pool. And number two, the results are within the concentration range used to make the calibration. This green check mark is quite important. It verifies the spectrometer has seen a sample similar to this one and has correctly interpreted the spectra. We all know how dependent the flour milling industry is on ash concentration to measure process efficiency, quality. It is associated with pushing those pennies out of the wheat kernels. Ash is what is left over after you burn off all the organics. And we just spoke about the fact that NIR sees the vibrational energies of organic molecules. So there's a discrepancy here. That's right. NIR is not directly looking at ash. It has always been a secondary correlation to something else. So what are we doing? When measuring ash concentration in wheat flour, we are mostly looking at the carbohydrates in the wheat bran residual. Since bran is loaded with these carbohydrates, the NIR can see that the bran is in there, and then we calibrate that spectral response back to ash concentration. It works very well, and it has worked very well for many years. Before the flour millers implemented full spectrum technology, like back in the 80s, you were looking at the color of the flour, relating the color back to bran concentration, and then relating the bran concentration to ash. So it was essentially a tertiary correlation, and it did not produce a very linear response. That is why back then you would have to have separate biases for spring wheat, winter wheat, soft wheat, and sometimes even different mills, A mill, B mill, C mill. But with modern spectrometers, the ash concentrations are beautifully linear and with a high level of accuracy. Still, I think it is important for people to understand that ash is an indirect measurement in flour when we're using NIR spectroscopy. Assuming a properly functioning NIR spectrometer and a robust wheat flour calibration, these are the industry standards. Moisture and protein plus or minus 0.2 at 1 standard deviation, and ash 0.02 at 1 standard deviation. They can be better or they can be worse, and this is due to the accuracy of the reference laboratory. Sometimes sample presentation can play a role in this as well. When looking at the overall accuracy of an NIR program, the #1 largest source of error is the reference method, and the second largest source of error is typically sample presentation. If both of these factors are in control, you should get good NIR results. So if someone presents me with data that fits within these industry standards, I know the NIR is working well and their laboratory is doing a great job. One of the things I really like about NIR technology is that I can predict, for the most part, how the instrument is going to perform in the future when I walk away from it and leave it at a customer site. When I have developed a good, robust calibration, implemented that calibration, and review a series of validation results, those results fit nicely into a Gaussian distribution. I get a lot of phone calls from customers talking about their data, and my mind goes straight to this bell curve. For example, they could say, today I got a 56 ash, but the lab said it was a 59 ash. I quickly calculate the 0.03 difference and know it falls within 2 standard deviations of what we can expect. If this is a problem for the customer, I am going to ask more questions about more samples. Recently, I had a customer call me and say one of their samples on their NIR deviated more than 2% from the laboratory for protein. According to our good old bell curve, that is extreme and unexpected. They said all the other samples read within 1 or 2 standard deviations. My conclusion was that something was wrong with the laboratory results or the bags got mixed up. When you start to think about your results in terms of the bell curve, you can quickly solve the majority of the discrepancies you experience. No one expects the NIR to produce numbers exactly what the laboratory says every time. We have to consider the statistics, which is also what I mean is we have to fall back on the science of the technology. It is a mathematical certainty. 5% of your NIR results will live beyond 2 standard deviations. We have to live with this fact and not overreact to this variation. So please, if anybody ever wants me to help them analyze their flour data, I am more than happy to run a quick statistical analysis and help you figure out what is going on. All you have to do is contact me and we'll go through the data together. Now I would like to bring up some points when implementing or introducing a new NIR spectrometer such as the NIR Master into your mill. The average lifespan for an NIR is approximately 10 years. So implementing a new NIR will bring additional features, networking capabilities, and overall change. Change is good, but change is not always easy, and sometimes there is resistance to change. Here are some points I would like you to consider based on my experience. Prior to NIR installation, have a conversation with your IT department about how the new system should be integrated into your network. I realize in some locations, networking may not be feasible. In this case, you will want to look into some seamless approach on getting the data into your reporting management tools in a timely and accurate manner. If you want direct remote access to the NIR computer, your IT department can help you decide the best way to do this. Having these internal discussions and being prepared will help reduce the amount of time to implement these structures. And on the other side, Buki can help you answer questions your IT department may have regarding what is possible to do within a network. Flour millers are using available technology more and more, and I'm getting a lot more questions about how to network NIR equipment. However, there are still a lot of mills writing down NIR results and then typing these results into another program. Again, I realize some of the locations within a mill may not be wired for network access, and if this is the case, I would consider looking into a solution for this. I encourage anyone still writing down their NIR results to investigate the utilization of a LIMS system or some other kind of reporting system. Now, some of this should go without saying, but I want to bring it up because I have installed a lot of NIR spectrometers in which the laboratory did not have any samples prepared, or they used their current NIR as reference data, or the sample sat for long periods of time in plastic bags losing moisture. When this happens, the customer does not get the full benefit of implementation while the NIR expert, like me, is on site. Then it's like we're playing catch up. When I say collect 10 samples per product, this means 10 hard wheat flour samples. It can be spring or winter wheat, that's not a problem. If you run soft flour, because soft flour is quite unique from hard flour, then 10 soft flour samples. If you're doing whole wheat flour, then you'll want to collect 10 of those as well. Doing this work in the beginning allows me to get a clear picture of how accurate the NIR is going to perform after I leave. We are not just validating the NIR. We are looking at the overall NIR program with enough data in the pool to offer a good statistical analysis. The good old bell curve doesn't work too well with 1 or 2 samples. I can easily identify sources of variation in your NIR program. It is our first point of reference, and together we can make decisions on how to improve accuracy or verify that all is good and you are well on the road to using your NIR every day. Doing this work will enhance your overall confidence of your new NIR, and confidence is a huge part of the process, as I will discuss later. So I recommend the quality control managers or the people, the administrators that are going to be in charge of the NIR to spend time with the new NIR before releasing it into everyday production. You will find differences from your old NIR to your new NIR, and you'll be able to better teach the operators how to manage these differences. You will also find the potential for mistakes and take corrective action, and you will have time to gain confidence in the NIR and project that confidence onto the routine operators. How long do you need to spend with the NIR before you release it? I would say at least a week or two. NIR vendors have done their best to make the software interaction as easy as possible. However, you still have to enter information into the system. It is a hands-on system. You should experience all the potential nuances that could happen to an operator on third shift. Trust me, taking this time to learn the system yourself will prevent those middle-of-the-night phone calls in which the operator is yelling, "The NIR ain't working." Now, I don't mean to pick on third shift operators because they have a tough job in the middle of the night, but these are the stories I hear. I get the phone calls too, first thing in the morning. "I don't know what they did last night, but we can't run the NIR." Please, 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 utilize all the available security features to prevent people from poking around where they don't belong. With the Buki NIRware, you have multiple user levels with defined functional ability. Using these features can prevent a myriad of future headaches. One of the features about the Buki NIRmaster that flour millers really like is that it has two lamps, a primary lamp and a secondary lamp. When the primary lamp burns out or loses intensity, the secondary lamp automatically kicks in. And note, this is something you're really going to like. You will not need to worry about checking your bias when this happens, nor you will have to check your bias when you replace the primary lamp. It is all perfectly aligned. The intensity is identical. And in addition to that, changing the lamp is super easy. It may take you 5 minutes at the most. You're going to spend more time shutting the instrument off and pulling off the cover than actually replacing the lamp. So there's also a lot of features within the Buki NIRmaster for performance verification. There's an integrated laser reference. We have internal and external referencing that will help accommodate for current instrument conditions and different path lengths. We have a system suitability test, and it is run typically every 24 hours. And that system suitability test will tell you every single day that your NIR, your NIRmaster, is performing perfectly. In addition to the system suitability test, we also have another more comprehensive diagnostic test called what we call the Nadia. And then if we run a Nadia test, that can let the service engineers know exactly what is going on with your unit. All of these things together give you the confidence that your NIR is giving you reliable, accurate results. And if you have any concern about the NIR functioning properly, we can easily generate reports indicating what exactly is going on inside your black box. Confidence in NIR. This has been my message all year. It is so important. Well, the cost of confidence, or lack thereof. And these are the 3 problems I have seen through the years. Problem number 1. The operators, well, let me back up a little bit because I do have management or QC managers. They're working closely with the NIR. They have a better understanding of the statistics and they know what to expect. But it's one thing for management to be confident. It's another thing for the operators. And that's the point I'm trying to make here. So for the operators, problem number 1, they never trusted NIR to begin with, which means they're going to be highly dependent on the reference lab. And you're not going to get the numbers from the reference lab in a way that's going to be able to help you in the efficiency of your process. So you're essentially running a blind process. The NIR is just something they have to do, and they just end up relying on their intuition and senses. And I can imagine most plant managers do not want that. Problem number 2. They didn't trust the previous NIR model. Well, this lengthens implementation of a new model. And when the NIR is accurate, you can get pushback from the operators. So if you imagine that maybe the process is running a little off and the ash is reading something that they didn't expect, they're not going to trust the NIR. And that's something else that you don't want. And then problem number 3, and I see this as the most costly problem, and I've seen big problems over the years when this happens. The operators don't think about the result. They release the product anyway. And so we have to encourage the operators to truly think about the results that they see and how it applies to load out or what's going to your customers. You know, it can take just one bad sample reading, 4 or 5 standard deviations out, for an operator to never trust the NIR again. So we need to do what we can do to prevent that. So here are some tips that I have to solidify NIR confidence. Do good reference analysis. Understand your accuracy. And I have to say that most of the data that I see out of the laboratories of flour mills is really, really good. You guys are doing a great job. But you also have to understand what your limitations are in the laboratory. Also, bias the NIR appropriately. What I call do not chase your tail. What do I mean by do not chase your tail? Make the bias adjustment. The bias adjustment should be outside the standard deviation of what you expect. So for example, somebody that's chasing their tail, they'll run a series of samples and they'll say, oh, well, I need to change my bias for moisture. I'm going to go up 0.2. Okay, fine, he goes up 0.2. Then the next month, he runs a new series of samples, and now he says, oh, I've got to decrease my bias by 0.3. So he goes back down 0.3. And then the next month, same thing, goes up 0.1. And he ends up right where he started. He was making bias adjustments within the expected accuracy of the whole model. So in other words, he was chasing his tail, but from his perspective, he's having to make all these changes, and the NIR is inaccurate when in fact the NIR was very accurate. One thing that a customer of mine did to help with his operator's confidence is he put up a whiteboard next to the NIR master, and whenever he got the wet chemistry results back, he would show the comparison. So when the operators would come up to the system and run a sample, they could see how accurate the Buki has been for the last week just based on those analyses. And over time, that really helped with operator confidence. And you should set up reasonable limits. And these limits, the warning limits and critical limits, and have some kind of a decision-making process that makes sense to the operators. Control your variables as best as possible. And ask for help from the NIR experts. It doesn't hurt to ask questions and to help, hone in on what is going to be a good NIR program. So at this time, I would like to introduce a new member of the Buki NIR portfolio. In addition to benchtop NIR solutions, we now offer process NIR solutions. NIR Online is an established company started in the early 2000s by 2 NIR experts with a long history with NIR technology. They developed a robust and powerful NIR sensor that has state-of-the-art software features. Over the past 10 years, NIR Online has successfully installed hundreds of NIR sensors into the agricultural industries, including flour milling. Buki is proud to welcome NIR Online into our product portfolio. Please contact me if you have any interest in understanding how a process NIR sensor can benefit your bottom line. Improving the control of blended wheat protein to 0.1% will bring a huge rate of return in a short amount of time. These are some of the comments that I have heard about the Buki NIR Master. And I'll give you a chance to read through these and may touch upon one or two of these. I am not seeing any operator-to-operator variability. That is because of the ease of sampling. There's no more packing. And even if you pack the sample down, you still get the same number. And so that helps control this variable. This one was funny. I called a customer and asked how the reference laboratory was doing in comparison with his Buki numbers. And he says to me, I don't have time to run my laboratory. I trust the Buki implicitly. So that was great. The machine tells you every day if your lamp is still good. Well, that's due to system suitability tests that's run every 24 hours. Love my Buki ash numbers, and that's always good to hear because as we talked about earlier, ash is a secondary correlation. I opened the instrument to replace the lamp for the first time and there was not one speck of flour inside the system. That's because the instrument is IP54, which means it's dust-proof. It'll actually take a light water washing too. So, the last one. I can track everything the operators are doing with the NIR on third shift. The Buki NIR Master records every single thing that you do. And so even if you open up the cover, it records that. So you can always track what is happening. Well, that is the end of my presentation. I'd be happy to answer any questions that you may have. I'll take this time to take a peek and see if there's any questions. Oh, here's one. Can I add samples to your standard wheat flour calibration? Absolutely, and I recommend it because this is another way to generate confidence. If you run good laboratory and have that spectra combined and send it to us, we will incorporate your data into the calibration so that you can be confident that your samples are represented. Okay? Well, I don't see that there's any more questions, so thank you again for your time and attention, and have a great rest of your day.